Hello everyone, welcome to day 0 of our course 100 Days of Deep Learning and AI Engineering. Before we write any code, before we train any model, and before we talk about ChatGPT, agents or large language models, we need one thing first, a clear roadmap. Because learning AI with a roadmap can feel confusing. One day you hear about neural networks, the next day you hear about transformers, then someone talks about RAG, agents, fine-tuning, embeddings, vector databases, and deployment. Everything sounds important, but the order is not clear. So in the first video, I want to show you the complete journey. This course is not designed to be a hype course. The goal is not just to say AI is changing the world. The goal is to understand how AI systems actually work, how to build them, how to improve them, and how to use them in real projects. This roadmap is divided into 100 days. We will start from the basic idea of a neuron, then move to deep learning, convolutional neural networks, sequence models, transformers, large language models, RAG systems, AI agents, multimodal AI, deployment, and finally a complete capstone project. This course is designed for beginners, students, researchers, engineers, teachers, and everyone who wants to understand modern AI properly. You do not need to be an expert before starting, but you should be ready to learn step by step with patience and practice. The most important thing is this. We will not jump directly to advanced tools. We will build the foundation first because without foundation, advanced AI becomes only copy-paste. Now let's divide this journey into 3 major areas. The first era is the foundation of deep learning. In this part, we will learn how neural networks think, learn, fail, and improve. We begin with the simplest idea, a perceptron. You can think of it as a small decision-making unit. For example, if you want to decide whether an email is a spam or not, the model looks at features and makes a decision. At the beginning, this decision may be wrong, but through training, the model slowly adjusts itself. From there, we can move to multi-layer perceptrons or MLPs. This is where deep learning really begins. Instead of one simple decision boundary, we allow the network to learn more complex patterns. We will study forward propagation, loss functions, and back propagations. These are the heart of deep learning. Forward propagation means the model makes a prediction. Loss tells us how wrong the prediction is. Back propagation tells the model how to correct itself. Then we move to training dynamics. Here we ask practical questions. Why is my model not learning? Why is the loss unstable? Why is the training accuracy high but validation accuracy is low? How do optimizers like Adam and AdamW help? What is dropout, batch normalization, and what is learning rate scheduling? These topics are extremely important because in real life, building a model is not just writing model.fit or training for 10 epochs. Real learning comes from debugging. Then we move into computer vision. We will study convolutional neural networks, pooling, residual networks, transfer learning, and GradCam. For example, we will not only train an image classifier, but also visualize what the model is looking at. After that, we study sequence models. This includes RNNs, LSTMs, GRUs, tokenization, embeddings, and attention. These ideas prepare us for transformers. By the end of era 1, you will be able to build neural networks, train them, debug them, and apply them to tabular data, images, and sequence problems. Once this foundation is clear, we are ready for the architecture that changed modern AI. Era 2 is the transformer revolution. Most modern AI systems today are based on transformer architecture. Large language models, chatbots, code assistants, translation systems, summarization tools, and many multimodal models are built around this idea. But we will not treat transformers like magic. We will break them down slowly. We will learn self-attention, multi-head attention, positional encoding, residual connections, layer normalization, encoder architecture, decoder architecture, cross-attention, and transformer inference. A simple way to understand attention is this. When a model reads a sentence, every word does not have equal importance. Some words need to pay more attention to other words. For example, in the sentence, the cat sat on the mat because it was tired. The model needs to understand what it refers to. Attention helps the model connect related words. After understanding transformers, we move to large language models. Here we study how transformers become LLMs. We will learn pre-training, scaling, instruction tuning, in-context learning, fine-tuning, LoRa, QLoRa, and quantization. This is where the course becomes very practical. We will not only use models through an API, we will understand what is happening behind the API. For example, when you ask a chatbot a question, the model is not searching the internet like a human. It is predicting tokens based on patterns learned during training. Understanding this helps us understand both the power and limitations of LLMs. By the end of Era 2, you will understand the architecture behind modern AI models and how to adopt them for specific tasks. But modern AI is not only about models. A useful AI product is a complete system. Era 3 is about building real AI systems. First, we study RAG, which means Retrieval Augmented Generation. RAG is important because LLMs do not know everything and they can make mistakes. With RAG, we connect a language model to external knowledge such as documents, PDFs, research papers, course notes, company policies, or a website. For example, instead of asking an LLM to guess an answer, we first retrieve relevant documents, then ask the model to answer using those documents. This makes the system more useful and more trustworthy. Next, we study agents. An AI agent is not just a chatbot that answers questions. It can use tools, follow steps, search information, call APIs, remember context, and complete the tasks. But we will also discuss the dangers of wrong tool use, hallucination, prompt injection, and unsafe automation. Then we move to multimodal AI. Modern AI is not limited to text. It can work with images, audio, video, and documents. We will study vision transformers, clip, diffusion models, and image-to-text systems. Finally, we reach the capstone. In the capstone, you will combine everything: deep learning, transformers, LLMs, RAG, agents, evaluation, deployment, monitoring, and responsible AI. The goal is to build a complete project that can go into your portfolio. For example, you may build an AI research assistant, a course teaching assistant, a document question answer system, or an intelligent domain-specific assistant. So this is our journey. We will start simple, but we will not stay simple. We will build layer by layer. First intuition, then theory, then code, then projects, then real systems. My promise is I will explain every topic in simple English with visual diagrams, examples, and practical implementations. We will avoid unnecessary complexity, but we will not avoid important concepts. If you follow this course seriously, by day 100, you will not just know AI terms, you will understand how modern AI systems are designed, trained, evaluated, and deployed. So welcome to day 0. In the next video, we will begin with the most basic building block of deep learning, the artificial neuron. Let's start this journey together. See you in the next video. Until then, let me know which topic you are most interested in.